The other day, I was talking with my wife, and we were discussing why humans should go to Mars, or should send probes to Mars. Let me briefly introduce her. She's a pediatrician. She's working at the hospital, in the pedopsychiatry department of the hospital, and she spends her life trying to relieve suffering kids born with severe conditions. I am a scientist. I'm working since 15 years on the mission InSight, on the instrument of this mission, and I spend my whole life trying to tune very complex instruments that will be sent at the surface of other planets. So the content of our discussion could be summarized like that. Why are we spending a lot of money and a lot of effort to send these probes to other planets where we could use this intelligence and these resources to help solve the everyday problems here on Earth? So, on May 5th, 2018, last May, the InSight probe has lifted off from the Vandenberg base in California. This was the first mission to Mars sent from the west coast of the United States. Of course, this was not the first spacecraft sent to Mars. This is actually the 54th spacecraft sent to Mars. 54 space missions to Mars, with, let's say, half of them successful, because Mars is hard. It is very difficult to get a mission there. So, and even the rover Opportunity has spent approximately 10 years roving on its surface. For Russia and for Europe, we have only succeeded in making a space probe survive a few seconds, a handful of seconds. So that's really hard. And it costs also a lot of money. Do not try to get something to Mars unless you have a few hundreds of millions of dollars in your pocket. Hundreds of millions. And this is closer to $1 billion if you want to land something and deploy it. So, therefore, only rich and powerful nations have the capability, of course, and the wallet to send missions to Mars. And let me tell you, in order to convince the space agencies of this nation to send your mission to Mars and not do something else with this money, you must have a fairly good science question, a $1 billion question. In the early summer of 2012, I was at the Jet Propulsion Laboratory in Pasadena, California, with the InSight team. The InSight team was rehearsing for the last step of the selection of the InSight mission. It is called the site visit. We were very excited but focused. Of course, in a few days, we would be championing our mission in front of the NASA board. The NASA board has been mandated to carry out the evaluation of our mission and to see if we were able to make the promise real of what we did. So we were absolutely focused, and we had at the same time it was really difficult to put forward all this mission because the instrument that we wanted to put forward was a kind of novel instrument. It was a seismometer. This was the team that we were on. At the same time, yes, even if it was difficult, even if the mission was still at stake, we were very excited, and it was also an achievement, a lifetime achievement to be here. Of course, we were French, and the father of the seismometer was here. It is called Philippe Lognonnet. He had spent maybe 15 years in order to promote this science and to try to convince France to found the seismometer. So it was a real achievement being here to prepare for this event. It was also a very big achievement for the handful of French engineers that were here. They have been working on the instrument since 20 years, and they were here preparing for that. It was also an achievement for the American team and for the European team that joined us a few years ago, believing in this science when at some point nobody cared about. And of course, it was an achievement for me. I was a newly appointed professor at SuperAero. I had been chosen to present the instrument in front of the NASA board, this very instrument, this seismometer. in order to convince this board that the instrument made the mission worth it. You remember the billion-dollar mission? It was not that easy. It was not that easy because we were trying to promote a mission with a seismometer. What does it mean? A seismometer, as you may know, is an instrument that detects earthquakes. When somewhere there is a quake on the planet, it detects the tiny vibration that it felt when you put it on the ground. So this is not some kind of wow instrument that people say, oh, this is awesome. There are nice images, there are nice sounds. No, not at all. It's a very intellectual instrument. And you have to analyze the signal very deeply to reveal its true content. However, it's an awesome instrument. Why is it awesome? It's able to detect motion of the ground of approximately the size of an atom moving. When you've got a quake somewhere, it emits vibration all over the planet. Some of these vibrations go at the surface. They are called the surface wave. But some of them go in the interior of the planet. They go through the crust, through the mantle, and some of them even go through the core of the planet. So what happens when you put a seismometer at the other side of the planet? It records those waves who have not traveled the same path, who have not seen the same rocks. But the signal that it retains, the signal that it records, keeps the trace of the rocks it went through. And therefore, quake after quake, it illuminates, from our perspective, the interior of the planet. There is a quake here, it illuminates here. There's a quake here, it illuminates here. And quake after quake, therefore, you've got a view of the interior structure of the planet. Just like when you put some sensor on your belly, when you are pregnant, and then you are able to record the sounds, the infrasounds, with and see the size and the structure of the baby, the head of the baby, when you put the head of the ecography on your belly. That's exactly the same thing that we were trying to do. So, as you understand, it's all about understanding the interior structure of the planet. All planets were born, all rocky planets were born approximately 4.5 billion years ago. In the same vicinity, they share the same composition. They were born from the same gas nebula, and approximately at the same size, at the same place. Yet, like some twins, they do not have the same fate. Of course, Earth is the living world that we know, with oceans, with volcanoes, with earthquakes, with an atmosphere that we can breathe, with a comfy 15 degrees for us. And it is full of life, as you see here. The moon is a dead body without any atmosphere anymore. It has only a few quakes remaining due to the cooling of the crust and due to the Earth's tides that make it squish like that. Venus is you know, the morning star or the evening star. So it's the twin of Earth, but it's some kind of evil twin. At its surface, you can feel a toasting hot 400 degrees Celsius. And if you stay there, you would be squashed by an atmosphere which is as dense as you would feel 1 kilometer below the oceans, with a sky completely obscured, a sky obscured by sulfuric acid clouds. It is a kind of hell, actually. And Mars. As far as we know, the early Mars looked like a little bit like early Earth. It had probably a reasonably dense atmosphere, some flowing water, probably some earthquakes, and surely some volcanoes, and maybe some oceans. But slowly, the interior engine stopped working. Then the crust of the planet was broadening, and then the magnetic field stopped, allowing the atmosphere to escape, to vanish. And now Mars is a desert. So by sending InSight, the InSight mission on Mars, we will have some clues about how did it happen. How did this planet went from a living planet to a slowly dying planet? Quake after quake, as I explained, tremor after tremor, we will refine and sharpen our knowledge of the interior structure of Mars, allowing us after to feed our models and to refine them in order to understand all the process that went. So why should we go to Mars in that respect? We should go to Mars to know that past and maybe to predict our future by knowing this science. But this is not enough. 2 years after the nominal mission of InSight, there will be another mission going to Mars. It will be a rover, a 6-wheel small rover, just like the Curiosity rover that is on Mars in the Grail crater. This Curiosity rover is a geologist and is studying the atmosphere. So the rover that will come on Mars at that time is called Mars 2020. But it will be not completely a geologist. It will be a little thumb rover. Why a little thumb? Because its main goal will be to retrieve samples from Mars. So it will be rowing on Mars, collecting samples based on their biological interest, putting them in sample containers, and letting them behind, just like little thumb, waiting for the next mission, the sample return mission, to come and bring them back to Earth. This little thumb rover, Mars 2020. Just like a little sister. But why should we bring back samples from Mars? Of course, the instruments that we send there are the outcome of the finest technology that we have today. But it takes time, to design these instruments, to make them robust enough to withstand, the environment on Mars and the travel and everything. So there is a price to pay for that. So it takes 10 years, and the performance of this instrument is not as good as the one that we have on Earth. For instance, if you take a phone which dates from 10 years ago, a robust phone, waterproof phone, it will never be as fancy as the latest smartphone that you get. So it is mandatory for us to bring back these samples, to take them back on Earth, to analyze them with the up-to-date instrumentation, and maybe in 10 years from now, reanalyze them in order to find something. But this something has to be outstanding enough to justify the $1 billion that we will spend in this little thumb rover and in the sample return mission. So it should be the kind of discovery that typically makes a mind change, just like when humanity went from flat Earth to round Earth. Also, the kind of discovery that Copernicus made, by changing the point of view. Earth was no more at the center of the universe, but merely a planet among others, a planet orbiting the sun. Therefore, in these samples that we bring back from Mars, we might find life, traces of life or current life. And this will be a huge revolution in our way of thinking. Why? Because if life has come on 2 planets of a solar system which is in the suburb of the galaxy, can you imagine that it will not exist elsewhere? The universe might be then full of life. So it is tempting to see in all these efforts a waste of money, Or I've heard even worse. Sending rockets is a man's thing, or sending rockets is the pure expression of male chauvinism, selfish chauvinism. You know, we've got children that die on Earth from war, from starving, from lack of vaccination, and you spend money in that. But nothing could be less wrong. Nothing could be less wrong than that. Of course, nurturing a child requires food, requires a lot of attention, but it requires also dreams. When I was 12, my uncle offered me a book written by a scientist called Carl Sagan. In this book, he wrote that humanity was at its prime childhood, that we were somewhere on the shore of the cosmic ocean, waiting for our toes to dip in. In this book, he connected the wisdom of the ancient Greeks with the latest discoveries in planetary science. He also invented the disk. It were not compact discs in the 70s, but he invented the disk that was put on the flanks of the Voyager mission. The Voyager mission was sent on an escape trajectory to the nearest star. And on this disk, there was hundreds of recordings of Earth sounds, from baby crying to singing of the whales. How can a man sending singing of the whales or baby crying to the nearest star be expressing his power? It's more of a child dream. It's a child dream so strong, so powerful, that once grown up, you have no choice but to pursue. This is the Voyager disk. I am in front of you today because I read this Cosmos book. And as far as I know, most of the people, the vast majority of the people I've met working on these missions, do this job because they believe in such ideas. They believe in such dreams. They believe that they can make a difference by studying the past and trying to foresee what may be our future. This is not about power. This is about dreams. So, why should we go to Mars? We should go to Mars to tell the story of what we invent, that we had. We should go to Mars to dream for our children in order to make them better humans. Of course, my wife is right. Our world is somehow broken, and as ancient wisdom says, it is a duty that we have to fix it every day of our life, to make our best to fix it. But in order to go forward, we must also set our eyes on the horizon and think to the world to come. And this cannot be done without knowing our past and dreaming our future. Going to Mars will help us on that. Thank you.